So to my mind, that last example wasn't that exciting, finding the area between two curves, but it is a staple of, for example, the AP Calculus exam, so we wanted to be sure to cover it. To me, much more interesting is questions like this. So look at these two functions, y equals 1 over square root of x and y equals 1 over x squared. If I just showed you this graph, you couldn't tell me which one it was. Both of their graphs qualitatively look like this. So I'm interested in finding how much area is under each of these curves, starting at x equals 1, going to x equals b, but then letting b go off forever to the right. So we're going to imagine a shape that is infinitely long, and we're going to wonder about how much area we'll get under it. Probably infinite, right? I mean, if the shape is infinitely long, doesn't it have to have infinite area? Doesn't that sort of make some intuitive sense? Well, let's see here. So we know that the way to find areas under curves is by doing an integral. So here we're taking the integral from 1 to b of 1 over the square root of x. But there's a better way that we can write that if we want to use our power rule. 1 over square root of x is really x to the negative 1/2 power. So we can use our power rule. We add 1 to the exponent. We get x to the 1/2 over 1/2, evaluated from 1 to b. Dividing by a half is the same as multiplying by 2, right? So this is really the same as saying 2 square roots of x from 1 to b. Fundamental theorem says plug in the top number, plug in the bottom number, and subtract. So just 2 square roots of b minus 2. We're going to have an applet for you to explore this in a minute before we come to some conclusion. So this is how much area we get under this curve from 1 to b. Let's do this other curve, 1 over x squared, which really looks the same. Although let's think for a second about which one is actually higher. Which graph is higher up, 1 over square root of x or 1 over x squared from 1 to b? When x equals 1, they're exactly the same. They're both 1 over 1. So the y value here is 1. But as soon as I go beyond 1, this curve starts to go down faster. So if this curve here were, say, 1 over the square root of x, the 1 over x squared curve would come underneath. But qualitatively, just looking at them, there's no way to tell which this is. It could be either one. We can do the same thing for this function, 1 over b, 1 to b. Again, instead of writing this as 1 over x squared, we would prefer to write it as x to the minus 2. So then the fundamental theorem says we add 1, we get x to the minus 1. That's not what the fundamental theorem says. The power rule says that. We evaluate that from 1 to b. This is a pretty ugly way of writing something that's not so messy. X to the negative 1 is 1 over x. Putting a minus on the bottom, we can rewrite this as minus 1 over x from 1 to b. Now the fundamental theorem says plug in the top number first. So minus 1 over b minus 1 over 1, which is the same as minus 1 over b plus 1, which to me looks a little bit nicer as 1 minus 1 over b. But all these are the same, so you can use whichever one you like. So now what your job is to take the applet and explore what happens. You're going to have to change the function to get to the second one. But what happens when b gets bigger and bigger and bigger? How much area you get under this graph? How much area you get under this graph? You're looking at a shape that is infinitely long, and the question is, must it have infinite area as well?